let's recap. So I'm going to show you a little animation here. This is going to examine the Leo, Mio, Hio, and Geo orbits. And so you can see them all kind of running here. This animation is going to play through, and we're just going to do a quick review of some of these orbits and some of their uses. Let's first look at Leo, the low Earth orbit. It is a circular orbit, less than roughly 2,000 kilometers, about an hour and a half to 2 hour orbit. RadarSat is a good example of this. It has a polar orbit. Remember, that's 90 degrees, and it's great because you pass over every spot of the Earth, get a nice close image. The Iconos 2 is an imaging satellite, and it's sun synchronous polar, which means that it's following the sun, so it's always getting the same time of day, so you never have shadows. So that's a clever type of orbit to use for a low Earth orbit. There's also MEO orbits, which are usually circular, 10 to 20,000 kilometers, which is a 5 to 18 hour period. And these are great for GPS. You can see large portions of the Earth. So you can see they all connect with this geostationary orbit and with each other. So you have constant coverage over the entire Earth. So that's what's giving us sort of this network of coverage. Moving on, there's a highly elliptical orbit, the HIO. It's an elliptical shape. It goes from about 500 kilometers to 50,000 kilometers, typically 8 to 24 hours. It spends a lot of time above the North Pole, moves very quickly over the South Pole, unless you change your argument of perigee to study the South Pole instead. So these are Molniya and Tundra orbits if you want to study things like the North Pole and different areas in the Northern Hemisphere. And last we have geostationary orbits at 36,000 some kilometers. You have to look up the exact distance away from the center of the Earth. Period is 24 hours, same as the Earth. And so there's satellites that may be put into a constellation with this TDRS and this low Earth orbit satellite, so that they're constantly communicating with each other. So what you're going to see here is if we have a ground station in Washington, D.C., and we want to constantly communicate with this satellite here, DC can't see that low Earth orbit satellite. But if we pause this right about here, then DC can communicate with this TDRS satellite, which then will communicate with the low Earth orbit satellite. Or it could bounce to here and back to here and see the backside of the Earth. So because DC doesn't have a direct access, you can use these geostationary satellites to give it access to spots where it normally could not see. And that is recap.